Okay, so let's get started. We're doing linear inequalities today. So the first thing I want to talk about is what exactly is a linear inequality. So go ahead and take a look at these two graphs. Think about what is the same, what is different, what do you think, or why do you think that the second graph looks the way that it does? So spend about 30 seconds analyzing it, and then if you have any comments, go ahead and say them in the chat or out loud.
I think the second graph is different because it's talking about everything be in that part of the line.
Yeah, so it's shading. That whole pink part, we call that shading. So it's kind of telling you that anything in this area of the graph is a part of that function or that equation. And so that's kind of the main difference. Is anything else different other than the shading? Take a look at the slope, the y-intercept, the x-intercept. Does anything else change?
Whatchamacallit? The equation.
Okay, so the equation itself is different. What's different about it?
It's an equal less less than or equal to.
Okay, so this right here, this is not less than or equal to.
Oh, it's
The other one. This one's greater than or equal to. Yeah. Greater than or equal to. Because remember that the less than sign looks like an L. So you can always think about it that way. If it looks like an L, it's a less than sign. If it's not, then it's greater. So yeah, we have a different symbol. So on the left, this is just a regular old linear equation. This is just a linear equation because it's equal. What is the slope of that equation?
-3/5.
-3/5, exactly. This is y equals mx plus b. So we know the slope is -3/5 and the y-intercept is +6. So that's all, we know how to do that. We've done that for the last 3 weeks. But on the right-hand side, I have a linear inequality. And when you have a linear inequality, that symbol tells us is going to add something to the graph. So in this case, that symbol told us to shade above the line. Why do you guys think it's asking us to shade above the line?
Maybe it could be any of those points.
Right, because the answer basically, because remember, we're talking about inequality, so there's solutions to that inequality, and all of those solutions is everything on the line, but also everything above the line. And we're going to talk about that in a little bit, but basically every tiny little point above that line, including all the points that are on the line, are part of the solution to that inequality. Now, one last question. How do I know that it's going to be shading above and not below? What do you guys think?
Because it's greater than?
Because it's greater than, exactly. This is a greater than sign. And so that tells us to go above. And we'll talk about this in the next slide. But basically, the symbol that you have in front of you will tell you whether you're going to shade above or below, and it's also going to tell you one more thing. So on this next slide, we're going to copy what I'm going to write down. I want you guys to copy down. Okay, so these are my inequality symbols, and we're going to talk about what they mean. So can I have a volunteer read for us just what's on the page right now?
When graphing a linear inequality, the symbols tell you the type of line to use, dash versus solid, where to shade of the.
Okay, so it tells us if it's going to be dashed versus solid, and then whether you're going to be shading above versus below. So we're going to make a little organized chart. Okay, I want you guys to copy this down. Okay. I could have made that a little bit better, but that's what we're working with. Okay. So kind of like a little tic-tac-toe. And I'm going to put each of the symbols in these boxes. So I'm going to start with my greater than, and then my greater than or equal to. And then down here, I'll put my less than, and then less than or equal to. And in case you need a quick little reminder, you can also write that this is greater than, and this one down here is less than. Okay, now, when you have a greater than symbol, or greater than or equal to, either way, if it's pointing to in the greater than direction, what do you guys think? Is that going to be shading above or below?
Above.
Yeah, that's going to be above. So in here, we're going to write above. All right, shade above. Now, when it's less than or equal to, that's going to be shading below. All right, so the two greater than symbols tell you to go above. The two less than symbols tell you to go below. But then, like Lauren was reading, there's another thing that these symbols tell us. These symbols tell us if the line is going to be dashed or solid. Now, what does that mean? On the previous slide, let me just erase a couple of these dots here so we can see it very clearly. On this previous slide, the line that we had was solid. It was a solid line. And that is because we had a greater than or equal to sign. So whenever you have a greater than or equal to, or a less than or equal to, if it has that little equal to part underneath, this is going to be a solid line. And if it doesn't have that, if it's just greater than or just less than, it's going to be a dashed line. We say dashed line. You might see dotted line. Either way is the same thing. It's going to be, instead of being solid, it's going to be either like some dashes or some dots. And we'll go over what that looks like in just a minute. All right, so I'll give you guys about 30 more seconds to about a minute to finish copying this down. Does anybody have any questions so far? Okay. Who still needs a couple more seconds to copy?
Me.
Okay, take your time.
I finished.
Okay, and then I know Lauren just got here, so Lauren, if you want to like take a picture of it so that I can move on to the next slide and then just keep copying it at your own pace.
I took a picture.
Awesome. Okay, so now let's actually see what this looks like. So I'm going to go through two examples of graphing. So for these two examples, you guys could kind of graph it on your sheet of paper if you want to copy down the graph itself. But more than anything, I just want you to write down what I write down. So the graph itself, if you want to, you can do it. Otherwise, let's just write down a couple of things. So first of all, I have this inequality. So go ahead and write that inequality down. Okay, so there are some things I already know about this inequality because it's written, it kind of looks like y equals mx plus b. The only difference is that I have a greater than symbol instead of an equals sign. So if that's the case, what do I already know about this function or this equation?
It's going to be dash.
Okay, you're right. I want to get to that kind of at the end, but before I talk about that, let's just talk about the slope and the y-intercept.
The slope is 3.
Slope is not just 3, but
3, negative 3.
negative 3. And what's the y-intercept?
7.
7. And then, like it was mentioned before, the greater than symbol tells us two things. So this tells me what type of line is it going to be? Is it going to be solid or dotted? Dash.
Solid.
Let's go back, look back at your chart. If there's no equal sign underneath it, what do you think?
Dashed.
Yeah, this one's going to be dashed. And since it's greater than, will it be going to be shaded above or below?
Above.
Above. And Ijara, I know you just got here, so I'm going to go back one slide. I want you to just take a quick picture of this screen and then copy it in your notebook while I'm working on the next problem.
Okay, thank you.
Okay. All right, so now we have everything we need. And I can go ahead and graph it. This goes back to how we graph functions. So who can remind me, where do I begin? What's my starting point?
Y.
The y. Good, the y-intercept. And the y-intercept is 7. So I know that this means I have a point at 0, 7. So I'm going to go to that point, and that's my starting point. And then where do I go from there?
You have to mark the rate of change.
Right, the rate of change or the slope. The rate of change is -3, but I know that that's the same thing as -3 over 1. So what are the directions? Where do I go?
Left 3. Up 1.
Remember that it's rise over run, so you have the right idea, but
down
Rise.
3.
Go down -3 and then go to the right.
yeah, there we go. So it's down 3, yeah, and then right 1, because the 1 is positive, right? So the -3 tells me to go down and then 1 to the right. So I'm going to do that. Down 3, 1, 2, 3, and then 1 to the right. And I'll do that a couple more times. So down 3, 1 to the right, down 3, 1 to the right. All right. So I have a few points. Now I need to draw my line. But remember that I don't have a solid line. I have a dashed or dotted line. So what I'm going to do, instead of, how I usually connect it nice and make a nice straight line like this, well, I can't really do that this time. So I'm just going to make as best as I can. This is in no way perfect. It's a little crooked, but that's okay. That is my dashed line or dotted line. So that's what it looks like. And then my final step is to shade above the graph. So if I'm shading above, is that on the right side of the line or on the left side of the line?
Right side.
The right side, exactly. So I'm going to go ahead and I'm just going to shade this. So everything above the line, and notice I'm shading all the way to the corners. Everything gets shaded. And I'm done. Okay, that is my final graph. So do I have any questions on how I did each of those steps? Notice that the first two steps are exactly the same as when you graph a linear equation. Same idea. You find the y-intercept and you start there. And then with your slope, you can find the next couple of points. The only difference is that now the line is either dashed or dotted, or solid, I mean. And then you also have to shade. So it kind of adds 2 extra steps to the process. But do I have any questions?
Why is it a dashed line?
Because this goes back to the chart, okay? The symbols tell you 2 different things. The symbol tells you where to shade and what type of line to use. So since I had a greater than symbol, I know that I have to shade above and I need to use a dashed line. And we'll do another example where it's going to be different. So let's check out the second example. Now I have y is less than or equal to -3 over 2x plus 6. So let's go through all of those steps again. I need to know my slope. I need to know the y-intercept. And because I have a less than or equal to symbol, I need to decide if it's going to be above, below, solid, or dotted. So take a couple seconds to think about the answers to this to yourself. See if you can identify all of those things. And then in just a minute, I'll ask people to say it out loud. But I just want everyone to think about it first. Alrighty. So who can tell me what is the slope?
-3 over 2.
Perfect. -3 over 2. What is the y-intercept?
7.
6.
6.
6, my bad.
And then what does my less than sign tell me to do? Less than or equal to?
It's a solid line below.
Good. Solid and below. Awesome. So now I graph. Where do I begin?
On the y-intercept.
Y-intercept 0,
0, 6.
6. Right there. And then from there, where do I go?
Down 3 and to the right 2.
Awesome. Now remember, this fraction is a negative fraction. So the whole thing is negative. But when you actually think about what that means, you can either put the negative number with the numerator or you could put it with the denominator, but you're not going to put it on both. So I could have -3 over +2 or +3 over -2, but I would not have -3 over -2. Okay, so whenever your fraction is negative, you can either put the negative in the numerator or the denominator, but not both. Either one will give you the same exact line. Okay, so in this case, Ajira said down 3 and 2 to the right, so it looks like Ajira was talking about this fraction. And that's correct. So this one's going to be down 3, 1, 2, 3, and then 2 to the right. Down 3, 2 to the right, down 3, 2 to the right, and there's a few dots. Do I have questions about that, what I just explained? Okay. Yeah, so this was down 3 and to the right 2. What would be this other one? What would I do in that case?
Up 2, left. I mean, up 3, left 2.
Yeah.
Yeah, up 3, left 2. And I'll show you now how that still works. If I go back to the y-intercept and I go up 3 and left 2, that still gives me, it's still part of that same line. Okay, so that's why you could do either one. Either one works. And now, okay, so now I have a solid line, so I can just connect my dots as usual. Well, let me make it a little bit better. There we go. There's my solid line, and now I can shade, and I'm shading below. So if I'm shading below, does that mean on the left side or on the right side?
Left side.
On the left side.
Yeah, left side. So kind of underneath and to the left. And just like before, I'm shading everything. Okay, there it is. All right, so again, very similar to just graphing normal lines, but we do have to add those last two steps and make sure that we're shading in the correct area. I see one last question on the chat, which is, how did I know that the 3 was negative? Again, since the whole fraction was negative, I could put the negative symbol in the numerator, or I could put it in the denominator, and both of those options will work. That's why it's negative, because it was negative to begin with. All right, so go ahead and try one on your own. So in this case, you're not going to get to graph it, but you're going to look at a graph and then figure out what is the inequality. So it's kind of backwards of what we just did. And I have a couple of questions that'll help you get to that answer, okay? So on your own, take about 5 minutes, take a look at this graph, figure out the slope, the y-intercept, and then is it dotted or dashed? This should say solid, my bad. Is it dashed or solid? Is it above or below? And then put that all together and see if you can figure out the inequality. So I'll give you guys about 5 minutes. Feel free to answer or ask any questions in the chat and I'll go ahead and answer them. Good, I'm seeing some correct answers in the chat. Once you have all the information you need, see if you can actually write the inequality. You still have about 2 minutes, so if you're a little stuck, you're not really sure where to go, make sure you're asking questions, guys. That's the best way to get answers, ask questions. Don't be afraid. We're all learning. Okay, about a minute left. Okay, finishing up. 3, 2, 1. All right, let's go through it. So first of all, who can tell me what is the slope? There were two, they were kind enough to give us 2 nice points on this graph from which you could find the slope. What did we get?
3.
3.
3, good. 3, you could either do rise over run. On this graph, rise over run is pretty easy to do. So I would do that, 1, 2, 3 up, and then 1 to the right. So we know that's 3 over 1, or just 3. What's the y-intercept?
-4.
Good, -4. Right here, down at the bottom, they show it to you very, very clearly. So we know the slope, we know the y-intercept. Now, is this shading happening below the line or above the line?
Below.
Yeah, this one's below the line. And is that line dotted or solid? Dashed or solid? This is dashed. Okay, so now we have all the information we need. First of all, what symbol am I going to use if I have a dashed line and it's going below?
Greater than.
Below. Below.
Below.
Oh, less than sign.
Less than, yeah, less than. I know it's going to be a less than sign because it's below. It kind of makes sense, right? Greater than goes above, less than goes below. Alrighty, so now I put it all together. So instead of writing y equals 3x minus 4, I'm going to write y is less than 3x minus 4. I just take the slope and the y-intercept. And that's my answer. Now, just a heads up, you guys will have homework on this, and the homework is exactly like this problem. I literally copied this from Khan Academy, you guys, okay? So on that homework assignment, they will give you a graph, and then you have to write the inequality, just like we did in this problem. So make sure if you're stuck on it, if you're doing the homework and you're stuck, you could always go back and watch this portion of the video just as a refresher for how to do this type of problem. But does anybody have any final questions on how to do this? Okay. All right. So next up, I'm going to graph another one, but there's something a little bit different about this inequality. What do you guys notice?
There are 2 sides.
There's only one symbol, but
It's a different. It's not.
The standard.
yeah. Oh, and I see a great answer. I'm going to call you out, Naomi, because I love the keyword you used. Naomi said the y is not isolated. Right? The y is not by itself. So we know that this is standard form. But remember, we've talked about standard form before. Standard form is kind of trash because it doesn't tell us like really any good information in order to graph. So I can't really do anything right now. What I have to do first,
Solve it.
yeah, is convert it to slope intercept form. In other words, I need to isolate the y. So I want you guys to write this down. All of the steps we're about to take, I want you guys to write it down so that when you're doing your homework, because this might come up in your homework, we know how to do it. But we've done it before, so this shouldn't be too difficult because we definitely have done this before with equations. The only difference is now we have an inequality, so some things might change.
We're gonna have to add a 0, right?
Add a 0? No, because that's when you're trying to figure out the x-intercept and the y-intercept. Right now, we're just converting it to slope-intercept form. Sounds kind of similar, but it's a different process. What we're trying to do is try to get the y by itself. So we're trying to push everything else over to the right side. And in order to do that, what should be my first step?
Subtract 2.
Subtract. Yeah, we're going to subtract 2x.
2x.
Mm-hmm. Okay, so that leaves me with negative 5y is greater than or equal to. And then how should I write the terms in the next line?
Negative 2x minus 20.
Good job, guys. Negative 2x minus 20. I want to put my x in the front because I want it to look like y equals mx plus b. Now it's almost there, but the y is still not by itself. What needs to happen next?
Divide.
Good. And what am I dividing by?
Negative 5.
Negative 5. Does that ring a bell to anybody about something I might need to do?
Yes. You
What?
need to switch the
Yeah,
greater than or equal to a less than or equal to.
exactly. Because I'm dividing by what?
Negative.
A negative.
Negative, yeah. Since I'm dividing by a negative number, when you're dividing by a negative number and you know you have an inequality, that should ring all the bells, okay? That tells me that I need to flip my sign. So I went from being greater than or equal to being less than or equal to. And now I just divide everything on the right side. So I know I'm doing negative 2x over negative 5, but that's going to be a fraction anyways. So what should I leave it as?
2
2
over 5.
negative
X.
Good. I heard 2 over 5.
negative.
But-
I mean positive. Sorry, positive.
Yeah, why is it positive?
Because there's 2 negatives.
Good. 2 negatives make a positive. Exactly. Perfect. And now negative 20 divided by negative 5?
Plus 4.
4.
Positive. So plus 4. Okay. We did it. Not too bad, right? You guys already know how to do this. Not too bad. We'll do a couple examples too, so you guys will get that chance to practice. And can somebody say one more time, why did I flip my sign? It's very specific. Why did I flip my sign? You guys said it before. Say it again. Why did I flip it from a greater than or equal to?
When you divide by a negative with an inequality symbol, you will flip the symbol because you're dividing by a negative.
Exactly. Perfectly said, Chloe. Thank you. It's because we're dividing by a negative. That's it. All right. Now I have everything I need. Now I know my slope. Now I know my y-intercept. And then my symbol will tell me a couple things. So what is my slope? Good, 2 over 5. What's my y-intercept? Good, positive 4. And my symbol, less than or equal to, tells me to do what?
Solid.
It's a solid line.
Mm-hmm.
And it's shaded below.
Solid and below. Perfect. Now let's go through it. I start at the positive 4, 0, 4. Where do I go from there?
Up to right 5.
Up to right 5. All right, here we go. Up to 3, 4, 5, right 5. Up to, and then 1, 2, 3, 4, 5. All right. I have my dots. Now I can make my line. It's going to be a solid line. So that's nice because I can make it nice and straight. Perfect. There is my line, and I'm shading below. So there is my inequality. So basically, this was, at the end of the day, was very similar to the previous problems we've done. But since we started in standard form, we had to take that extra step of isolating the y, of turning it into slope-intercept form. So it's always important when you get a question like this, you have to think, okay, is it in standard form or is it already in y-intercept form? And if it's in standard form like this one, you always have to convert it first before you can graph. Do I have any questions on anything that I did? We're going to do one more example. So if you have questions, I might be able to answer them on the next slide. All right. So here we have one more. And just like the previous problem, I want you guys to write down what we're doing in the first step, which is converting. Okay, so go ahead and we're going to copy this down. So negative 12x minus 6y is greater than or equal to 5. And I'm trying to solve for y. I'm trying to get that y all by itself. So what should I do first?
Add 12x.
Good, that 12x has to go away, but we're not going to subtract it this time. Why are we adding?
Because it's a negative.
Yeah, because it was negative. So we need to do the opposite, which is add. So now I have negative 6y is greater than or equal to 12x plus 5. What's my second step?
Divide.
Divide. And I'm dividing by
-6.
negative 6. So just like in the previous problem, this now becomes y is less than or equal to. And then what do I get over here? So I have 12 divided by negative 6.
It would be
Negative
2.
2.
Negative 2x. And then 5 divided by negative 6.
5/6, negative 5/6.
Yeah, we're going to leave it as a fraction. This one's a little weird, isn't it?
Yeah.
We haven't really had that yet where the y-intercept is a fraction, but it does happen sometimes. So I wanted to include this problem because we're not going to be afraid of fractions in this class. We're better than that. Okay, what's my slope?
-2.
Negative 2. What's my y-intercept?
-5/6.
Negative 5/6. And my symbol tells me to shade where?
Below and shaded.
Below and
Solid.
solid. Good. Okay. So even though I have a fraction for my y-intercept, that's okay. That's totally okay. We're going to just work with it. So this is 0, negative 5/6. Now, negative 5/6 is very, very close to what?
6.
Negative
No,
6?
no.
1.
Yeah, very close to negative
Negative.
1. Because it's almost negative 6/6. It's just a little bit less. So I'm going to put my dot just a little bit above the negative 1. And then my slope is negative 2, so that tells me to go where?
Down 2.
Down 2.
To the right one.
Right 1.
And 1 to the right. Good. So when I count down 2, I'm just going to stick a little bit above whatever line I get to. So down 2, I go 1, 2, and then 1 to the right. I'm staying just a little bit above that line. Okay, that's all. And for the record, you guys would probably never see this on a test. Like it wouldn't make you graph this because it's a little too like complicated. It doesn't need to be that complicated. So you would probably not have to graph this, but this question was taken from Khan Academy. And on Khan Academy, what they have you do is correct, like pick the correct graph. So they have like a multiple choice of 4 different graphs, and you have to pick the correct one. So you won't have to graph it, but you might see the graph and have to recognize the correct one. So if you're a little stressed about how I'm doing this, try not to stress too much, because it's going to be a little bit less complicated when you actually do it. All right, so there's my dots. Now I have a solid line. And I'm shading below. So here we go. There is my lovely inequality. Do I have any final questions? Next slide, you guys are going to try one on your own. Again, not graphing, but pretty cool. You'll do some of those steps. Cool. All right, so again, you guys don't have to graph it, but I do want you guys to do everything that goes before the graphing, okay? So we have an inequality, we need to convert it to slope-intercept form, and then identify the slope, the y-intercept, and then whether it's gonna be a solid or dashed line, above or below. So all of those steps, I want you guys to try that on your own, and then once we have all those answers, I will graph it on my screen. So go ahead and take 5 minutes. 5 minutes, convert it to slope-intercept form, and then go from there. Any questions are welcome.
It could be decimals, right?
Yes, but remember that if something is a decimal, what do we want to keep it as?
Fraction.
Mhm. About 2 minutes left. Okay, 15 seconds left. All right. Cool. Time is up. Let's go ahead and go through this. So I saw a lot of correct answers. This is definitely another one where you end up with a lot of fractions, but again, we're not going to be afraid of fractions. They're fine, right? So I have negative 3x minus 4y is less than or equal to 2. And when you convert this into slope-intercept form, can anyone tell me the final equation or not equation, inequality that they got?
Y no wait, greater than or equal to negative 3 over 4x minus a half.
Good. Y is greater than or equal to negative 3 over 4x minus 1/2. So lots of fractions in this one. Did anyone get something different and would like me to go through the steps?
For the y-intercept, I got negative 2 over 4.
Oh, well, what's negative 2 over 4 simplified?
1/2.
There you go. So that was just Juan simplified it, and that was all he had to do. Alrighty, so now what's my slope? Slope is negative 3 over 4. Y-intercept is negative 1/2. Do I have a solid line or a dashed line?
Solid.
Solid. Am I shading above or below?
Above.
Above, yeah, because the sign flipped, right? So now I have a greater than or equal to sign. Okay, let me go ahead and graph. Again, because of all these fractions, do not stress if this is a little confusing, but this is negative 0 comma negative 1/2. So that's like right here. And then what are my directions? Where am I going?
Down 1 to the right 2.
And careful, we're looking at the slope though, not the y-intercept.
Oh, I'm sorry. Down 3 to the right 4.
Good. So if we put the negative up on top in the numerator, this is down 3 and then 4 to the right. Okay, so down 3, 1, 2, 3, and then 4 to the right. Down 3, 1, 2, 3, and then 1, 2, 3, 4 to the right. Okay, there's my dots. I have a solid line. And I am shading above. Now again, this type of question, if you got this on a test, it would more likely be a multiple choice question, not you actually graphing it, which is why on the Khan Academy, I have that type of problem, okay? It's gonna be more like a multiple choice question where you just have to pick the correct graph. So any final questions on this? Because we're just gonna do one last topic before we're done. Alrighty. Okay, so here's the final thing. Sometimes the question might ask you, which of the following is a solution to the inequality? And when you get that type of question, what you're going to look for is which of those points, this is very similar to what we did like last week. We're looking to see which of those points is located on the line, but also above the line, because we have that whole area that's shaded. So you're trying to see which of these points is in the shaded area as well as on the line. So I want everyone to take about 1 minute speed round, look through all those answer choices and try to see if they are in the boundary or outside of the boundary. And then we'll go through it together. Don't say anything out loud quite yet. All right, so what do we think? I see a couple answers in the chat. Let's go through them together. So for answer choice A, is it in or out?
Out.
In.
Ooh, in or out?
In.
Oh wait, that's out.
Out.
No wait, in.
It's in.
Okay, so 0,3, is that on the y-axis or the x-axis?
The Y.
Why?
That's the y-axis, yeah. So 0,3 is right on the line. So that's fine, that's in. What about 3,0?
No.
No, because that's on what axis, x or y?
The X.
X.
Right, that's right here on the x-axis. So that one's out. -4,0.
Out.
In.
In or out?
In.
Okay, in. I see another
In.
in the chat. Yeah, is that on the x-axis or the y-axis?
The X.
X.
Good, right here. So that's in. What about -6,2?
In.
Also in. -6,2 is right here. That's in the shaded area. That's good. What about 2,6?
In.
I'm seeing some outs in the chat, and then I'm hearing some ins. 2,6 is right on the money, right on the line. That one's fine. That one's in. What about 2,6?
Out.
That one's out because that's down here. Yeah, that is not in the shaded area.
Wait, miss.
Mm-hmm.
I think E might be out. It's like slightly off.
Like
Let me
a
check.
little bit.
Yeah, I was a little bit sketched about that one. This one's definitely a tough call. I think you might be right. I think it might be out. And in a little bit, we'll talk about how to know for sure. But we'll do that in just a couple minutes, okay? So yes, that one might be in, might be out. This one's kind of like a question mark. And for this one, I might want to use algebra, but I'll get to that in a second. All right, how about these? You guys try this one on your own. Take about a minute, look through all those points, see which ones are in, which ones are out. All right, seeing a couple answers trickle in. We have kind of different ideas, so I kind of want to talk about this one because this one's a little bit different. What's different about this one?
It's dashed.
Yeah, this one is dashed, and that's going to change some answers, so let's go through it. 0,3, in or out?
Out.
Out. Okay, well, it's right here, so it's on the line, so why do you say out?
Because it's dashed.
Because it's a dashed line. So think about it kind of like a boundary line, okay? Like if you're playing like basketball or tennis, there's a lot of different sports where if the ball like touches the actual line, it's good to go. But some sports, if it touches the actual line, it's out. So this is kind of one of those situations where if you're on the line, that's technically out. Okay, so like I can think of like in tennis, if you step on that line, you're out. When you're doing the what's it called? This when you're serving at the beginning. So this is when it's dashed, you can't be on it because it's a dashed line. It's kind of like you're gonna fall through, or there's the floor is lava, or something like that. So for that reason, A is out. How about B, 3, 0?
In.
3, 0 is all good. That's in the shaded region. Negative 4, 0?
In.
Good. It barely makes it, but it is in. How about negative 6, 2?
Out.
Good. That one's out. 2, 6?
Out.
Also out. And what about 8, 8?
In.
Out.
So it's on the line, kind of, right? But it's a dashed line, therefore it has to be out. So that's the moral of the story, okay? If you have a solid line, any point on that line is part of the solution. But if you have a dashed line, any point on that line is out. It's not part of the solution. So here, only B and C were the ones that were in. Do I have any questions on that? In versus out? Cool. Okay. Well, like I kind of mentioned before, sometimes you might have a point that you're not really so sure about. Like it kind of looks like it's on the inside, but it's kind of hard to tell. Well, in that case, you can use algebra. So sometimes you might get a question on a test where they just give you the inequality and then you have to know which ones are solutions, but they don't give you a graph. So if all you have is the inequality and no graph at all, this is where we're going to use algebra. And this is very similar to what we did last week with equations. Remember where we had to plug each value in and then see if we get the same answer at the end? Very similar. However, one little thing is going to change. So let's just take a look. So here I have to test each point. Okay, so I'm going to plug in each point and see what happens. With point A, answer choice A, what should I plug in for the X value?
-2.
-2.
-2 goes in for X. And then for Y, I put in +2. Okay, so I'm just plugging in -2 and +2. And now I'm going to go through and solve. So -14 times -2 gives me
7.
7.
I'm multiplying.
Oh.
28.
28, yeah, +28. And then -7 times +2.
-14.
-14.
Or minus.
Or -14. And then 18 minus 14 gives me
7.
7.
Wait.
Yeah. Wait.
14.
14.
14.
Okay. So now here's what I have. 14 is less than 4. Is 14 less than 4?
No.
No, 14 is not less than 4. So this is a nonsensical answer. It doesn't make sense. Oops, I didn't mean to circle it. I meant to cross it out because that one's wrong. So instead of looking for an answer where you have the same number on both sides, you're just looking for an answer where the inequality makes sense. So in this case, it doesn't make sense, so that's not a solution. Okay, let's do another one. Answer choice B, now I'm plugging in -4 for X and then 0 for Y. Technically, I don't know why I wrote -0, but that should just be a 0 because 0 can't be positive or negative, it's just neutral. Okay, a little bit of math here. You may use a calculator. What is -14 times -4?
56.
56. 7 times 0?
0.
Is 56 less than 4?
No.
No.
No, this one's out. Let's do one more. And this one is not a select all question, so as soon as you get the correct answer, you're good to go. Okay. Negative 14 times positive 2.
Negative 28.
Negative 28. Negative 7 times positive 2.
Negative 14.
Okay, so what's negative 28 minus 14?
Negative 14.
Negative 14.
Mm-mm.
Wait, 14.
Mm-mm.
Oh, no, I'm
Negative 42.
Negative 42. Yeah. How'd you do that?
You add.
Yeah, it's becoming more and more negative because you start in a negative 28 and then you're subtracting, so you get more negative, so in your head you're going to add. So this negative 42 is less than 4. Is that correct?
yes.
Yes, negative 42 is definitely less than 4, so this one checks out. This one's correct. So that's the process. So again, we're not looking for them to match because it's not an equal sign. We're just looking for the inequality to make sense. Make it make sense, okay? Negative 42 is less than 4, and that is a true statement, so that's the correct answer. Do I have any questions on this? You guys will get a chance to try it on the next slide. Cool. All right, go ahead and give it a try. Same idea. We're trying to figure out which one is a solution. So we're going to plug, you have to test each answer choice, plug it in, see if the resulting inequality makes sense or not. I'll start with 5 minutes, but you guys tell me if you need more at the end of those 5 minutes. Good, about halfway through. Halfway through. Okay, just about a minute left to finish up. You can send me your answers in the chat, and what I'm going to do is I'm going to go over the correct answer, but I will also go over one incorrect answer. So if you got it wrong, I could go over it to show why it's wrong. Three, two, one, and that's time. Okay. So what I want to do is, like I said, I want to go over the correct answer first. So who can share with me which answer is correct?
I think it's B.
I think it's B. Okay, I'm hearing lots of B's.
Yeah.
Let's check it out. So for B, I'm going to plug in a 2 and a 2. So 2 for both of them. All right, 10 times 2 gives me
20.
20. 5 times 2 gives me
10.
10.
10. 20 plus 10,
30.
30.
30. Is 30 greater than -4?
Yes.
Yeah, it is.
Yes, ma'am.
Yes, ma'am. So that is correct. That one checks out. That is my answer. However, did any of you have an answer that you thought was correct? You can put it privately or just say it out loud that you would like me to show why it's wrong.
A.
A? Okay, let me show you A.
Is that I forgot that there was a negative at the 4s.
Yeah, okay. So if you forget a negative, that's going to mess you up for sure. So here it was 0, -4. Well, 10 times 0 is 0. But then 5 times -4, what's that?
-20.
-20. Well, 0 minus 20 is -20. And is -20 greater than -4?
No.
No, it is less than, so that's wrong. Okay. So at the end of the day, it's just important to make sure, plug in those negatives. Don't forget about those negatives. They're very important. And then make sure you read it carefully at the end to determine if it's right or wrong. Any final questions on this problem or any of those that we've done before? All right, cool. So we still have 5 minutes. I'm not going to let you go that easy. I just want to do one last little thing. What was the problem where we weren't sure? Here it is. Okay, this problem where we weren't sure if E was in or out. Now we know that we can use algebra to figure it out. So I'm going to plug in that number and let's find out together because I'm not so sure either. Let's find out together whether this one is in or out. So I would plug in 2 for X and 6 for Y. What is -5 times 2?
-10.
-10, and then 3 times 6 is 18. What is -10 plus 18?
+8.
+8, right? Is +8 greater than or equal to 9?
No.
No, so that one was actually out. So whoever was like kind of sketched out by it, you guys were correct. That one was actually out. All right, and then super, super quickly, I promise this won't take too long. I just want to show you one little thing, and this is a good problem for that. I'm just going to plug in 0, 3 really quickly. This gives me 0. This gives me 9. I get 9 greater than or equal to 9. Is that true or false?
True.
Good. Why is it true?
Because it's
Because
greater
it's equal
than
to.
or equal to.
Good, because you have that equal to. Since it's equal to, this is correct. But if this had been just greater than, just like that, would that have been correct?
No.
No. So that's just one last little thing to watch out for, you know, just make sure that you have the correct symbol and that you're being very careful. All right, that is everything, guys. So like I said, there is homework. Oops. There is homework. I already put it up. 2 assignments due Friday at midnight, very similar to what we did today together in class. So if you're stuck on any problems, you can definitely go watch this video to just remind yourself what we did. And very good job today. I am very, very happy with the amount of participation I had from most of you participated. So that made me very happy. So good job. Have a great rest of your days. Some of your teachers, if they're in school, might not show up to your next class because of what's going on. Like they're still not letting them into the classrooms right now. Everybody's like outside in the courtyard because apparently there was a lot of flooding. So just check in with those teachers on Teams. They'll probably tell you what's going on. But if you have any questions, you can reach out to me and I'll do my best to let you know what's happening. So have a good day, guys. I'll see you tomorrow.
Have a good day.
Bye, Miss Lopez.
Bye.
Tomorrow.